två som saknas, va?
Yes. Just det är det. Welcome back. Data Innovation Summit 2018 with a brand new panel of highly esteemed experts in the field of AI. So we got a lot of questions from the delegates, probably the most questions of any of the panels, 3 pages. It's pretty impressive. And all of them are asking the same question, so we only had to print one really, which is, how do we prevent the robots from taking over? In all seriousness, no, there's quite a lot of concern about the safety and ethics of AI, and there have been some events this past week that are at the forefront of news and that kind of thing. So that seems to be what's top of mind for people. So let's just go and take a little round here around the table and introduce yourselves and say, how come you know anything about AI?
Right. So my name is Andreas Rosenqvist. I work for a company called Innovia. We are basically working with big data and artificial intelligence. That's the only thing we do. So we're around 55 experts here in Sweden, and we do a lot of things around NLP, a lot of deep learning, a lot of stuff in like banking, fraud, detection, etc. So quite wide area within AI.
Okay.
We've been around since 2012, so some time now at least. So a bit about us.
So you've been doing this for a while?
Yes.
Good, cool.
All right, so I'm Patrick Couch. I'm with IBM. I support the Watson efforts of IBM. I do business development. I focus on artificial intelligence, cognitive technologies, primarily focusing on the industrial sector in the Nordic countries, but I do have a broad grasp of what IBM is up to. And I think IBM's claim to fame when it comes to AI is, of course, the Watson splash made in 2011 when we brought Watson out of the lab, played Jeopardy quite successfully, and out of that has then come a lot of various applications. So I'm trying to bridge the IBM research work with the real world business value of those applications, basically.
Right. Okay.
So my name is Daniel Akinine. I work as something called a National Technology Officer for Microsoft. So I'm responsible for the Microsoft strategy and policy in this area. And I also work a lot with security, and I think security has been an explosion. You started to mention security as well, and so I work with technology trends and the combination as well with security in that kind of topic.
All right. Well, like I said, most of the questions we received from delegates are with regards to fear and safety of AI. I think we're all enthusiasts of AI, and at least I tend to always see, the possibilities before anything else. I think that's the hallmark of a great thinker in general. But there are concerns. So what are your thoughts on those concerns? Are they legitimate to begin with?
Right. I mean, I think there's a lot of, you have the most extreme versions where you basically train machines to kill people, which is a classification technology problem, so to say. But from an ethic aspects, of course, totally, for me at least, totally out of there. But the technology itself is like a knife or a car. It can be misused, but it can also be of a great value to humanity. I mean, we have a case where we actually are looking into improving brain cancer treatment through deep learning and image analysis in order to facilitate even better treatment plans, and that will actually, both. It will increase the survivability for that person, and of course increase the health and the world itself. But then, of course, you can misuse things, as anything. I would say.
The question is, you can misuse this piece of paper to give someone a paper cut.
Exactly.
But the question is ML analogous to researching nuclear fission? Some things have a higher risk profile. What do you think?
Well, yeah, I think your point is valid, right? And I certainly agree with you that I think you can view artificial intelligence as, Twitter, right? So Twitter had a great impact on the American elections, both for Obama and for Trump. Good, bad, you call it, but the implications are there, and the amplification is great. So I think, yes, I do think that there is legitimate reason for concern when it comes to the implications of what can be done with or through the use of artificial intelligence. Maybe not really along the lines of nuclear power, but it is certainly in that area, simply because the digitization of the world allows for an amplification much greater than anything we've ever seen before. So if you combine that with a certain concern about whether or not there are any hard stops for what will be possible with AI, then you get into these fear-oriented thoughts, I think.
Right.
So I think it is valid. I think people are legitimate in their concern, but I think really it's not so much a concern about technology as much as a concern for the people using the technology. So it's really a reflection on our own concern about ourselves, right?
Well, weapons of mass destruction is something that several of the panelists have brought up when talking about here. Are those legitimate examples, or are they failures of the scientific method in general? I mean, do they apply specifically to deep learning and AI and these kinds of things?
So I want to go back to the original question on safety. So we had this week the incident with the Uber car that kind of killed a person. And the question is really, what is the expectations that people have on this artificial intelligence? Normally, I think the expectations are that they should be so much better than humans. So that's not necessarily the expectations that we need to have, because right now people, if you are going to be operated, for instance, by a robot or a machine learning, people are expecting that to be 100% safe. But you are not expecting a human doctor to be 100% safe, because you can recognize yourself in that doctor, and you have some expectations that you would do something wrong. I can also accept that the doctor is doing something wrong. But we are looking at artificial intelligence and robots differently in that perspective. So we are not having the same expectations right now on AI. So the bar is much higher, I would say, for AI to really...
Is it unreasonably high?
No, I think why not? Why not have it extremely high when we have the opportunity to do that? So I think people will accept AI and things around us if we can prove that they are at least as safe as a human being would be administrating those kind of tasks.
You have two opportunities. You have Schumacher and AI, and then you have the median driver. And the question is, should you hold the AI driver to be better than the median driver or better than Schumacher? So under that circumstance where the woman was killed, there might have been many people that might have or might not have been able to prevent it, but perhaps the average driver might not have. And so the question is, was that a failure or not? In that particular instance, undoubtedly. But on a general national scale, are we willing to sacrifice the lives of people explicitly because we need to have that accountability?
But you see a lot of these support systems, as we talked about, like, assisting the human. I still believe we're in the era of weak AI, which is specialized AI on certain tasks that can actually assist the human, in some parts also actually remove the human for that particular special tasks, like hazard work or supporting. I mean, you have self-driving cars are coming, obviously, and then they will be there, but you have support systems today. I mean, like early brake warning, like actually auto brakes. I mean, that's been around now for a while, right? But of course we need to continue to drive the technology to improve these things, like unfortunately the woman that died. But as you said, would that have been prevented with a human only? Maybe not. So I think it's a combination of things. And then also, I mean, we are progressing in really rapidly within all of these areas, but we still are within, I would argue, the weak AI, which is targeting specific tasks to be able to do so. Not the general AI, which would be more of the replacement of the human itself. Right. So I think it's a combination of these. I don't know if you guys want to add anything in this.
No, I think you're very right. And I also think your point is very, very accurate in the sense that we do put greater demand on the performance of technology.
Yeah.
We are less forgiving, right? The human error is a well-established excuse that you can toss out. Like, okay, so what was the problem with the accident? Oh, the human factor, something, and then people are, oh, that's too bad, but I can sort of sympathize and understand with that. But if you say, hey, the ghost in the machine killed off the woman, you don't get much sympathy points for that. And I think you're right. We should shoot for something better. We shouldn't just replace what we can do manually with something automatically, right? We should do something more. But another point is also, I think, it's a question of, responsibility and unique situations and averages. So even if we can justify, the optimization of driving by saying, hey, 90% of all the deaths in traffic are caused by the human error.
Yep.
Implying if we get rid of the human error, we can save 90% of the lives. However, it would require algorithms to kill off the rest 10%. Now, the bottom line for that is a pretty solid argument, but it can't be convinced, it can't be used as a guiding light for us to figure out how to deal with the issue of responsibility and the performance of the algorithm.
Well, you could say philosophically that you're making an active choice if by deploying a flawed model, you could be saving half of the people that die each year. So that choice is still being made.
But you don't necessarily always know what choices you are making. So I can take the example for the self-driving cars. Do we know how safe they actually are?
No.
No, we don't know that because they have been running for hundreds of thousands of hours, yes. But if you compare that to human trafficking, it's like hundreds of millions of hours. So you don't have enough data to actually say that a self-driving car is right now better or worse than a human being. So that's kind of the dilemma. So should we then, what kind of certainty should you have when it comes to safety to put those kind of technologies out between people?
But you can't base all skepticism on a particular field, which is in this case now self-driving cars. But you see these as supporting system as well. You see it could add value of analysis for a doctor. The system may not give it's not giving you the verdict, it's giving you the support to give something, So I think that you go into the more extreme, of course, the self-driving cars that killed a poor woman, but we need also to see that there's such a wide usage of this technology, and it gives such a value to the human way of working and way of living that it's just fantastic, I would say. But of course, we have to take some of this criticism of are we ready to deploy self-driving cars? Are we having enough data to make sure that these are doing the job and doing that part? And you're combining so much technology, it's sometimes difficult to understand how did it actually come to that verdict of doing that choice in that particular moment. So I think that you have to it's high and low, and we need to be able to use the technology in all different types of fields.
Well, let's tone it down then to a more relatable example. Weapons of Mass Destruction uses a lot of example where they talk about how people might be discriminated against because of biased AI and that kind of thing. And it's not evident to me that the argument is made that there's something inherent in AI rather than a flaw in the scientific method. So just for instance, the simple statistical statement that the next person you are going to get mugged by is likely to be a poor person, but the next poor person you meet is not very likely to mug you. That is probably something that can trick a lot of humans, and that they might not really understand the nuance there, but it won't trick a deep learning model. And so is the fear legitimate that there will be these biases specific and inherent to AI?
Oh, certainly. And I mentioned this at during my talk earlier today, the fact that, just recently, earlier this year, in January, I think, gendershades.org published this review of how well visual recognition algorithms can recognize faces. And Microsoft was exposed, IBM was exposed, Face++ was exposed, and the basic outcome of that was generally visual recognition algorithms from these three companies perform very well. That's sort of number one. Number two, they perform exceedingly well when we look at white males. And we underperform terribly when we look at women of color, right? So that is not saying that the algorithms are racist, it's saying that there's a bias that crept in when the algorithm and the data sets were being used. Yeah. And I think that's just one example, a very clear
But that's also
example.
valid for hand sanitizers. If you put your hand in front of those infrared scanners, people with dark skin, with your watch, the Apple Watch, doesn't work if you have a tattoo.
Right.
That doesn't mean it's racist against my skin.
No, exactly. But it shows that things that we do not necessarily associate with technology, such as opinion or racism or whatever. But we give technology that simply by not being aware of how that is influencing the technology development. And I think what we need to do is certainly address that. Right?
Is that particular to AI?
No. Well, yes and no. It's very obvious when it comes to AI, but I think it's not unsolvable. Actually, I think that's a problem that you could address. So the thing is really, what is the model learning and what should the model really be learning? That's two different questions, really. And I think if you see all big technology shifts, they come with some disadvantages. But you can also apply AI to try to solve those kind of disadvantages as well. So there is research going on, trying to look at how can you use AI to get rid of biases as well. So it can look at data, find the biases, which you as a human wouldn't see, and try to get rid of it from early on. So I think you can use a lot of new solutions, technology solutions, to try to solve the bias problem as well. So I think that in a couple of years this will be much better. It will be tougher to find those kind of really bad design decisions that people have been making up till now.
So we're talking about models that are biased, and when you explain that a model is biased...
The model is not biased,
no.
The data is biased.
Exactly.
Well, the model might be telling you something, and your conclusion might be that it's biased, and you're using confounding variables to explain that, but the model is not incorrect, otherwise it wouldn't have a high accuracy. If it has a high accuracy, it's correct.
It depends on the training data.
Well,
Would you be only
say
training on white male for facial recognition? That would be what it actually would be seeing.
Well, let's say you want to give loans. Loans are a good example, right. and let's say it's biased and discriminates against foreigners or something. And, the statistics say that foreigners are more likely to default or something like that. It's not because they're foreigners. That's a confounding variable. There are other factors at play, of course, but that's an issue of interpretability. Right. That's not a bias in the model. It's predicting well.
And this is kind of interesting because now you drops into like GDPR. So Article 21 defines, I believe it's Article 21, defines that you have to have a consent in order to use artificial intelligence based on that type of decisions.
Right.
So, there is of course some legalization coming into this in play in order to protect the consumer, but the models will be as good as the training material you feed it. And the models themselves won't be biased. They're based on the training material that you're feeding with and how you validate those models to make sure that you're hitting the mark that you want to hit.
Well, Daniel made a good point that we could use these models to understand exactly what it is that the bias is based on. So the prediction might be good, but it could give cause for us to investigate further.
Yeah.
Right, and I think that's sort of the promise, right? I mean, if we can get transparency, auditability, traceability into this domain of AI and all these great data sets, we can also get a better understanding of why are they performing a certain way, why are they interpreted a certain way, and that will give us a better sense of trust if we can understand the way data has been processed. So I think, and that is certainly more easy to fix in the technological space than in a human space out here, right? Because then you need to really, understand people, and people are pretty complex. But data and algorithms, yes, they are complex, but these guys out here, more complex.
What if the subject domain is so complicated that there is no easily intelligible explanation for something? Let's say you're going to give a loan, and you input thousands of variables, and they're all equally important. You do a PCA, and they're sort of all equally important. Should we not be using those models? Or the previous panel thought that that level of complexity should not be the purview of machine learning algorithms. We shouldn't let them do that kind of stuff. What do you think?
Yeah, I think that's an interesting question. So the thing is really, so if you have a model that says, I am 96% accurate, you say this data I give you is 96% accurate. How accurate is that answer, really? How accurate is it that it is 96% accurate? That's kind of a second question that people don't necessarily ask. And I think this is a very interesting question because we are moving now when you're having AI making decisions on you. It could be the government wants to make a decision on your social welfare, or if you're a foreigner and you want to stay in Sweden and you have a decision if you're going to be able to stay or not. You take a lot of input, and the model probably will make a very good decision. But what happens is that they will give you a decision, and you might want to challenge that decision. You say, tell me how you actually came to that conclusion, because this is impacting me. And then the government is basically saying, well, the model is saying that, or the algorithm is saying that, I have no idea. So then you get to a point in how accurate is really that decision, and how explainable is that decision as well. You have to be, I think, in the future, being able to talk about the decisions that are made in a much more intelligible way than
you have to weigh that against the benefits. Let's say that this model does so that you can cut down the lines to 1 week instead of 3 months.
Yes, you have to. You can't. I don't think you can argue and saying you're seeing so incredibly a lot of big advantages in economy or in efficiency when it's not safe from a pure law perspective, basically. So because then you're dismantling the law system and the right to explanation and all of that. So the persons that will have a negative impact, they will get such a strong negative impact, and I think that's actually bigger than the positive effect. You have to really look at both perspectives.
And I totally agree with you on, like, you have to have lineage now, especially now in this time, that you prove that this is actually how it has been done, this calculation, in order to come to that conclusion. It becomes very difficult, as we talked about earlier, when you combine things in especially deep learning and neural network type of, and it's very difficult to see how they actually end up to take that decision in a self-driving car, for example. But I think that now, because there are also skepticism about the technology, it's super important, of course, to have the lineage of seeing how do we actually get to that value. And that's why I think it's important to say that a lot of the things in decision making as a supportive system at this point. But then, of course, there will be things like we have read about in media, like kind of more of identifying individuals and segments and trying to push message towards them in order to change their opinions, etc. That will occur, and I mean that will always happen. But I do believe that lineage is really important at this stage.
So to counterbalance this, one thing that I think I watched both when Kasparov was fighting Deep Blue and when Watson was playing in Jeopardy, and also when AlphaGo was playing. And for me, those were like, I guess I missed the moon landing, so I didn't get it was the same for me. I'm going to remember those days.
Yeah.
And I think part of our obligation as scientists is to disseminate the information that we get to people. So communication is important. We have Feynman and all these important people that were charming and could explain things. What part of the picture are people missing that makes them worry more than see the potential benefits? In medicine especially, that's such an obvious case for me, where the benefits are so gargantuan that they far outweigh the negative impacts. And you guys have been so successful at this communication.
Right. Well,
what are your ideas on it?
Well, I think what people are concerned about are not necessarily the technological implications or the promise or the lack thereof of the benefits of using this technology. I think what people are concerned about is the lack of democratization, basically, that we are thinking as an obvious of course. I mean, we want to train expertise systems, we want to distribute them. If we can just get everybody on the net, everybody get digital, everybody will have access to the same thing. I mean, that's the great promise. But I think people that are concerned are thinking, well, that's usually not the case, right? There's often a skewing and a misrepresentation and a power elite that will benefit tremendously, and then there will be people that won't benefit from it. So I think the concern is more about how do we ensure that this benefit is evenly distributed. So I think we're not coming up against new problems. We're coming up against the same problems that give us favelas next to gated communities, and it's just impossible to justify that. It's very difficult to explain it to yourself what you're seeing, and the same will be true of if you have greatly support medical care only provided to the rich and famous, what's the benefit? So I think people are concerned more about how to evenly distribute the promise. I think people are on board on the potential, but they are concerned then when they see, again with the Twitter, comparison, most people were pretty happy when Barack Obama made judicial use of social media and got the presidency. That was great, right? People were happy. And then the backfired and, Cambridge Analytica and Donald Trump came along and people are not so happy. Same technology, just different type of use. When people see that, they're thinking, it's not the technology, it's the heads, right? And then they see, I don't want to amplify these people because the problem is great as it is already.
Right.
So I think, what Peter Parker, Spider-Man's Uncle Ben said about, with great power comes great responsibility. And I think people are understanding that and they're seeing the implications of that. And they're thinking if we don't have so much power, we don't need to be so responsible. That's probably more viable. It's a very defensive, dark and rather cynical view, which I do not support myself. But I think those are the types of things that are going on when people are concerned about the future we're moving into in terms of AI and digitalization.
So will things not move as fast as they could because people are so concerned? For instance, GDPR, and will organizations not deploy models because they're afraid of regulations or afraid of the feedback from the public?
Yes, I think it does. I think that's okay to not move as fast as you can as well. So I can give you one example, a Swedish example. So you had a municipality in southern Sweden, in Trelleborg municipality. They implemented an AI or algorithm more or less to deal with a lot of work that social workers were doing. And they were very, very successful. They took away a lot of routine tasks and the algorithms were basically doing all that stuff. And they could move those workers to other areas which they were more needed. So they got a lot of funding to try to expose that same model to the different municipalities in Sweden. And then they came to Kungsbacka municipality in Sweden, implementing the same model. And at that time, I think there's 12 out of 16 social workers that decided to quit their job because you were implementing this AI. So you're really seeing if you cannot really explain the value or really get acceptance from the people where you're, deploying these AI solutions, you're going to see a lot of negative effects. So you really understand what is the concern of people, what is really the concern of people, and how can we address that? Because otherwise, that kind of effect is going to hit you, and it's really tough.
Trying to put you on the spot here, but you're having very good answers that are sort of pragmatic. I think the point here is that people are scared of the practical implications of it, not so much the theoretical implications. And one question I'm wondering to myself is, the subject matter is quite advanced. Are we reaching a point in our society where the subjects that people need to make active, informed decisions on are beyond their capabilities? England went into Brexit. Perhaps you could argue they didn't really understand what the implications of that were. We're voted, so an economy, national economy, or an AI, how it should be deployed in our countries. How will society respond to these types of decisions when they can't necessarily understand it completely?
No, I think that is spot on, and I think we've been in this situation for a long time. I mean, we're being asked to make decisions on things we have no idea about. Should we be part of the EU or not?
Yes.
Should we have the same currency or not? How should I invest my pension funds? I have no idea. You ask me? No. So I think that's always a challenge, and it's part of the human condition to sort of be faced with a great responsibility and very little means to exercise it. And I think to your point, I think it's very valid to say it doesn't need to go so fast. I think the GDPR is a great thing. I think certainly we can slow things down a little bit and make people get on board, get people comfortable, make them more understanding of what we're doing. And I think same as, genomics or, gene therapy and all these things, great promise, but it needs to be figured out slightly, cautiously and with a lot of judgment, and preferably in a consensus-style manner, so that a lot of different opinions can be factored in.
Right.
So I think we are eager because, I mean, if you think of yourself as, I'm, equality for all, everybody benefit, go positive and all of that, then you have no wish for it to go slower. You just want to increase it, roll it out, and let's go, right? But when you look out, you say, hey, people have different opinions about how, what, why, when, if, under what kind of circumstances. To get all of that in, very difficult. I mean, look at the struggles of the UN as a body of consensus decision, right? Struggling to be efficient, but what's the alternative? I don't know, but I mean, we can't just say,
algorithms.
Maybe, but yeah, maybe, I don't know.
Perfectly altruistic.
It's goal-oriented, right? Reinforcement learning.
Incorruptible.
Save the planet as a goal and figure out the reward system. No, I don't know.
Well,
but I think
speaking of job replacement, I think that is a top-of-mind concern for a lot of people. And what I think is extra interesting is that it's very easy to give examples of where very highly qualified jobs will be replaced to great degrees. Not because the job is difficult, but because a lot of the extra work you end up doing in those jobs is menial. So lawyers do 80% worthless stuff and 20% worthwhile stuff, which means you could get rid of 80% of the lawyers.
Yes.
And the same thing with doctors. Maybe they only need to do the important stuff, and we can get rid of the time, which means the people. What impact will this truly have on society in the next 20 years?
But you have seen this type. AI is yet another type of technology, and of course we love it, and we believe that we could do a lot of good things with it. But if you look at the grocery store, you have already replaced a lot of people with this self-service scanning things. It's not AI, it's just a part of the technology evolution.
Right.
So of course this is a part of the technology evolution. Some of those people may lose their job, but maybe they go into other areas of taking their, guiding the consumer into something, assisting them into something. So I don't think that we've had this going on for a long time now. So it's no difference, I would argue, with AI than the way that technology have changed the way that we're living. Like a cashier in a grocery store. You do the scanning yourself.
Well,
and I certainly agree. I think AI may have a slightly accelerated potential impact than other technologies when it comes to job replacement, but it raises an interesting question about why would you want to have a job in the first place? Right? Most people would say, well, because I want to pay rent, I want to, have a, financial solidity, blah, blah, blah. Yes, but if that is taken care of, why would you want your job? And the people that would say, well, I still want to have a job because I love the job, I love the colleagues, I love what I do. Da, da. Okay, but those are things that are expressive of your humanness, right? Do you need to do that under the umbrella term of work? So I think work replacement is a misconstrued issue that we are going about addressing the wrong way, precisely to your point. It has always been there. Certain tasks should just be gotten rid of, the dirty, dangerous, dull ones. I mean, just goodbye to them, everybody happy, and then focus on what makes you human, what is great with being human. And I think Jack Ma at the Davos summit spoke about this very eloquently when he talked about how education needs to change. And I think that's just spot on, because why would we want to take on machine tasks? That's not human worthy. We do it because there's no alternative. But if there is an alternative, why would we want to do it? I don't think so. So I think people are not addressing it in a suitable way, really.
I like your comment there, because it's two questions. Will we have jobs tomorrow, and do we want to have a job tomorrow? And the other question is not that often asked, really. Do we really want to work? Because it's like we have been working, all human mankind, we have never been trying to not work.
Right.
But for the first question about will we have work tomorrow, I think that's a difficult one, because there's a lot of arguments saying, well, if you look at history, there has always been this transformation, and they are creating a lot of new work. And that's true, it has been. But the theory that we will have work tomorrow is normally based on that historical data. And that's not necessarily proof that it will be the exact same in the future as well. It is some input to that theory, but it's not proof that we will have new jobs. So I think very few people actually know what
Right.
will happen. I don't think there is any, real answer to that.
I tend to agree with you. I think humans give themselves a lot of credit for being very general purpose and very flexible and stuff, but really, all we're good at are throwing rocks and parabolas and sort of low speed dynamics and that kind of thing. So if the machines can replace everything that a human with an IQ of 80 can do, what do we do with 1/4 of humanity? Because it's not about whether you want to work or not. It's whether you provide me as a co-human any value that I would be willing to engage with you in that a robot couldn't do better, more efficiently, and anything else. It sounds crass, but if 1/4 of humanity is effectively worthless in terms of value production,
economical value. You have to, you're worthless maybe from an economical perspective.
yes.
But you're not worthless. I think that's.
But they still need to be sustained in some way.
Yes.
So the alternative would be if robots or something provides for us.
Right, but so this is heady stuff. I mean, I don't know exactly where we're going with this, but I think you do have a point, right? But I think also, if you, again, with Jack Ma and what he said about education, basically said, we need to become poets, we need to become artists, we need to become the things that we are on our spare time. What do we do on vacation? Well, maybe we have a chat over a beer and just socialize. That socializing has a value because we're group people. We're not individuals or islands in that, I forget the movie's name, but we are not. We're socially oriented creatures, right? So just having a gang to hang with, that has great value, period. And if I can do that instead of going to work, why not, right? But you're right. I mean, we certainly need to figure out how to sustain a growing population.
9 billion people, poets.
Yes, put the art medal to the...
Short term, we need more data scientists, more coders, more hackers,
Yes.
Please give us more of those, because that's a constraint right now.
Yeah.
But looking at like you guys are talking about like way off there, then of course 1/4. But as you said, it's an economic value. It's not the human value.
Yeah.
I mean, society today, we have people that need special help.
And only very
assistance.
few people are willing to pay millions for Da Vinci's paintings.
Yeah.
But your point is very good. I mean, what the artist does, or the poet does, is to create, right? What has never been done before, and that's what we want. We want people that can create stuff, new stuff, novel stuff.
What if
stuff that
computers
wasn't
can make
before.
better music?
They can.
They
To
can.
some extent already,
Yeah.
apparently. But I mean, taste. There's no right and wrong, right? You
But that
have
doesn't
your
remove
opinion.
your joy in creating music. The fact that a
No,
computer
exactly.
or another composer, for that matter, can make better music.
Everybody can create music. I mean, when the distribution of when the change happened in the music industry and distribution of physical goods became non-viable as a justification for your business, the music industry said, this terrible, it's going to go bad, right? What happened was people are creating more music now than ever before,
Right.
differently, but there are more people doing it, right?
Yeah.
And I think you're right. Maybe not the Da Vinci poets are the ones that we need to roll out in mass, but the data creative people are, and the best coders, the best programmers are the poets.
Yes.
Those that come up with completely new ways of attacking a problem, creating something beautiful, efficient, different. I mean, that's why why is this called the Data Innovation Summit? Because innovation is the shit. It's the difficult thing to do. People that are struggling, the companies that struggle the most with innovation are the ones that are faring the worst. Innovative people are always the disruptors, right? And I think that's what we need to figure out. How do we empower the awesome human brain to be as creative as possible?
Yep.
Supported by AI, yes.
All right, that pretty much wraps up our talk, and it was the fastest talk, not in time, but in relative time. So the outlook is bright, and I think this is a paradigm shift for humanity. So it's the place to be if you want to be doing something exciting.
Yes, definitely.
Thank you very much.
Thank
We will
you.
be back shortly. Tack så mycket.
Tack så mycket.
Welcome to Data Innovation Summit 2018. It's the last panel of the day. I hope you guys have been having fun. We have two outstanding panelists here to talk about IoT. Jon Lindén from Econo and Charlie Lagervik from Microsoft. Welcome.
Thank you.
So, tell me a little bit about what you do at Microsoft and Econo and how it relates to IoT.
So I'm part of a team that's called the Global Black Belt at Microsoft. So we are a specialized team focusing on different workloads, and my particular interest and focus is IoT. So I help both customers and partners get value from our product and technology, but also helping our engineers understand the needs and build the best products that our partners and customers are looking for from Microsoft.
And at Econo, it's all about IoT. We do machine learning for IoT. In short, we say we make connected things smart. And this has a background from the University of Borås, where a guy named Richard Koenig led the research on predictive modeling. And the outcome was a very lightweight software solution which enables us to actually run advanced machine learning out on the connected devices. Mm-hmm. So we can see everything, all the sensor data in real time, take instant actions, be independent or less dependent on connectivity, and actually do personalized training on each and every individual separate device. So that's what we do. It's an embedded software product.
Mm-hmm. All right. Well, IoT is top of mind on everybody.
Yes.
And we've heard it for 2-3 years now at most conferences. IoT is coming up. It's going to be big. It's going to drive lots of internet traffic and that kind of thing. And it certainly seems like it's picked up steam. From my perspective, I've seen at telcos that they've started to make businesses out of it. Has the uptick been as fast as predicted, or is it on track, or is it behind?
I think there's definitely a buzz around IoT with, I would say, higher expectations than we currently see in the market if you look at some aspects of it. On the other side, there's a huge adoption to this platform. I mean, it's a triple number growth for Microsoft when it comes to IoT. It's a very fast growing industry. And I think the industry, as you said, if you go to conferences, IoT is generating a lot of interest. And what we are seeing, at least from my perspective, is that we moved away from tryouts and POCs or pilots into real production systems and real rollout. So I would say that we are past the bus, but we still are pretty unmature when it comes to rollouts from an industry perspective. So most of the cases are, I would say, between POCs and real production environments.
That has to be the litmus test, actually putting things into production.
Yeah, definitely.
And what industries do you see being the leaders in IoT right now, in deployments into production?
I would say that it's certainly on the industrial IoT side, and the main reason is money. If you take the automotive industry, a car, it's unfortunate if your car stops and you have to pick it up the next day. But if your truck or your forest harvester actually stops, you start losing money instantly. So it's very much on the industrial side due to money. I very often get the question if IoT is just a buzz. In my opinion, it's not. I would certainly say that this is the fourth screen, but without the screen. That we had the TV, the computer, the smartphone, and now we have everything else that's being connected. And my main takeaway from the Consumer Electronics Show, CES in Vegas, in January was that no one talked about IoT. Mm-hmm. And I think the main reason is that it's a given. If it's not exactly. If it's not connected, it doesn't exist.
Ubiquitous.
It's kind of like something shouting in the forest. Right. No one is listening unless it's connected.
Right.
So it's a given. And I think that we're going to see a very rapid ramp up, but you have to find the business cases, and that's more in the industrial side right now.
All right, well, let's talk about what's driving IoT. Is it operational efficiency, or is it new revenue streams?
I think it's both. I think there is many of the bigger manufacturing companies, for example, are really looking at building a new relationship through IoT with their end customers and by doing connectivity to their products. But there is also a very cost-driven focus on improving the internal efficiency of the manufacturing environment. So I think there is both an agenda where you use IoT to drive new revenue streams, but there is also that lowering cost perspective to that, particularly around manufacturing. And then when you come to the consumer industry, I think there is still a lot of tryouts to find the right business models around IoT, where data is the new oil, but you really need to understand then what is the oil and how do you consume that oil and how do you present that. So for us at least, I would say that 70-80% of where we see the revenue streams generated for our customers is in the B2B world, and B2C is still pretty small when it comes to real revenue streams for our customers.
So can you give examples of the B2B streams that are...
No, but it's around service industries, for example. So we have Tetra Pak as a Swedish example that are using IoT to provide better aftermarket services for their machines, and also to help the service technicians to remotely communicate and understand status of machines. And I would say that is a pretty common, so to say, scenario now when it comes to manufacturing, where you could use that IoT platform to be close to physical machines, even though you are physically distant from those machines.
Is that why it hasn't accelerated like people expected? Because the consumer end of it hasn't really adopted it as fast as the industrial end?
We haven't seen it as much in the homes as we expected, in the cars and everything else. But just like Charlie's saying, on the B2B side, that's where things are happening. That's where the money is. And my experience when it comes to especially on the B2B side, everyone is very interested in and excited about new business opportunities, new revenue opportunities, but at the end of the day, you buy on threats and issues. How do you solve specific issues? Mm-hmm. That's what actually generates the budgets, that's where you can get money to spend, and that's typically where it starts. How can we solve a very urgent issue? And something like predictive maintenance is a no-brainer. I mean, you don't want the first call from your customer to be that your machine is broken.
Right.
You want to actually reach out to the customer saying that your machine actually needs some maintenance, and we're going to help you, and we know what you're going to do, and so forth. So it's definitely a very good case for how it's being used, connectivity in combination with smartness.
Let's talk just for a minute about what IoT actually is. We talked about before the show started smart TVs.
Right.
You can have these low power devices that don't even use Bluetooth. They use these mesh networks. You can have Bluetooth, you can have Wi-Fi, and you can have cellular networks. What kind of things, when people are talking about IoT, what do they really mean? And what's the bulk of it?
I think you are touching a really sensitive thing around IoT, that there is actually no definition of IoT. So depending who you ask, you will get different answers for that. But for us at Microsoft, IoT is really about providing value by having the combination of the things, the devices, the connectivity to the cloud, where you can take actions from the data that you get from these devices, and then put that back to change the context where the device exists. And I think there is of course the predictive maintenance scenarios around this, but there is also much lower hanging fruits, if you could say that in English, where you just get connectivity and get actually real-time insight to what is the context at the machine. So you don't need to apply pretty much any algorithm, just verifying that this is the sensor value. And I think that is one of the challenges that we see often when we talk about IoT, is that we tend to focus on the more advanced analytic or predictive maintenance scenarios, even though for a manufacturer or for a retailer it might be of huge value to just actually have some verification that this is the status, this is the alarm log, or this is the warehouse volumes that we have in store, for example. So I think IoT could be both those pretty or much more simple scenarios, but it could also be those, I mean, the value increases, of course, the more advanced things you do, but I think often we tend to focus on those, and the maturity might give us a huge value even in the early phases.
I think it's a very broad definition, and it basically lacks a definition. That's fine. Yeah. It's not an industry, it's not a vertical, it's a word that kind of aggregates a lot of things into it, Internet of Things, and that's good. Like I said before, we've taken the step from hooking up people with smartphones to actually hooking up everything else. And this is also where the combination of AI, machine learning, and IoT comes into play. Because with a smartphone, we always have a smart interface, which is the human who's operating it. You have the GUI and you have a smart human operating it. With Internet of Things, they have to become autonomously smart. Otherwise, with billions of connected devices, we're going to spend too much resources on manually supervising and managing all these connected things.
Right.
So everyone's going to work basically in control rooms. That should be the future work for anyone who's a teenager these days, unless we automate it. So we make things slightly more smart, which is a necessity, which is why these two are so closely related.
Right.
But I think also Internet of Things is also actually having things communicating directly with themselves as well. So building these closed, or actually combining those closed control loop systems that the devices themselves could generate if they are close to a machine or close to the device, and then combining that with having that control power of a cloud, for example. So I think what we often forget about IoT is that it's also the Internet of Things. So it should be the things themselves that actually communicate as well.
Right.
And it's not just about device to cloud and cloud to device. It's also between devices and trying to get a good context of what is actually the surroundings where the devices operate to make clever decisions on the edge. And I think one of the big trends we see now is that you want to combine the power of the cloud where you have all your data and where you have really advanced capabilities of building algorithms, and then bringing that capability down to the edge or closer to the context where the machines and device exist, and make local decisions where you don't need to loop to the cloud or loop back to the servers to make decisions. And I think we will probably just see...
Is that where things will be moving?
I think it will just accelerate. I think you will see more of that because the power that you get, I mean how quickly CPUs and even low power CPUs, how much more computer power you will get on those devices will just, so to say, increase the capabilities that you have on the edge. So the reason for sending things back to the cloud or back to the backend servers will become less and less, and you will use that to have an aggregated view or have a control and have a digital twin that you could then control the devices on the edge. But to actually run the algorithm, even though they are pretty significant, you will probably in the near future don't have that much hardware limitations even on the edge.
It's going to be a necessity that in order to manage this exponential growth in data, you have to take a layered approach. It's not going to be an either or.
Right.
And some things are better done at the edge, some things are better done in the cloud. Mm-hmm. Like, instead of aggregating 2.5 terabytes of data from an airplane per day, where most of that data is very relevant right now in real time, but the best before date actually exceeds pretty quickly, and where you can actually learn in the meantime and constantly, it's kind of like a Tamagotchi. The more you feed it, the better it gets. Same thing with a machine learning model. The more you feed it, the better it gets. That actually aggregate the knowledge in that model instead, so you can execute that continuously. That's a better way of processing that real-time data, and you're going to send curated and better data to the cloud, which is better suited for doing cross-referencing. Cross-referencing between your entire install base, like all your trucks, instead of that specific truck. That specific truck is better managed out on the truck, but all your trucks, the fleet, is better managed in the cloud. And also for manual supervision, the cloud is much better. For automation, the device is much better. So it's not, definitely not going to be a versus. It's not going to be an either or. It's going to be a combined. It's going to be a layered approach. It's the only way we can do this.
I definitely agree on that. And I think also where we see limitations now from an IoT standpoint, it's most often not the CPU on the edge, or it's not even the capabilities on the cloud or backend side. It's really networking. So sending data, and particularly if you want to send huge volumes of data, networking is even today becoming the bottleneck. And I don't think 5G or any technology will solve that, because the volumes of data will increase quicker than the networks will evolve. Absolutely. So the only way I see this happening in the future is that you need to be able to provide algorithm closer to the data, because you will not be able to move all the data up to the cloud. But you will definitely need to combine these. So you need to train the algorithm, you need to use the cloud or the backend servers for what they are good at, but you also need to be able to actually execute things and react to things quicker on the edge and on the devices. So definitely a combination.
Well, it seems like there's very many different types of devices in terms of their capabilities to connectivity and processing power right onto the device. I heard a neat example by a guy that had a lamp that would tell if it was on or off, and a little bit of intelligence like that, but not quite enough that it would maintain its own state and have a processor in it. Of course, it's just a light bulb. And the best way to handle that was, rather than have a super complicated state machine that would have lots of problems, it would use AI. And you could train the AI by saying good house, bad house,
Right.
when it made mistakes.
Yes.
And that would be an example of processing closer to the data. But how important then is AI in taking advantage of IoT? Is it just about measuring things, or is IoT, this, if we call it like a change, IoT that's coming, is AI an important part of that?
It's crucial. I mean, it comes back to if you want to do things more instantly. If you just rely on uploading the data and then processing and making decisions and sending back, let's take a truck. They typically upload the data once a day. When we talk latency in the telecom space, it's normally a round trip time. Now we're talking a day. You're looking at a day-old data. It's very hard to be predictive when you're looking at old data. Right. That's kind of the latency in that context. So there are a few things, some actions, some activities that will require instant decisions.
Right.
And then you want to automate those decisions, and AI, machine learning, is built for that purpose. So it is very, very intertwined. They're very related due to all these different things. It makes a lot of sense to combine AI with IoT because they are so related.
And I think there is also a huge value of trying to document that knowledge. And I think by using AI in the same scenario like you gave us an example, is where you have an operator that is sharing his knowledge around how to solve certain problems, or what does this situation mean, and you get that documented in, so to say, a feedback loop in an algorithm. I think there's a huge value of moving knowledge from the operator into the algorithm, because then the operator could focus on being creative and thinking about the bigger picture and solving real problems, instead of solving problems that could be solved by a computer from a repeatable solution. And I think AI also have, and we see more and more of our customer focusing on this now as well, is that the pace of change is just accelerating. And if you're working with data and you need to understand the data and the semantics of data, customers are now starting to use AI even for the ETL process, so understanding what is actually this data. So AI is even infused in the metadata model generation of the data itself. So it's like, it's AI of AI.
You need a set.
Yeah, it is. And I think this is probably something that also will accelerate, combined with IoT, that you will not have the luxury of defining all the information model that comes from these millions and millions of sensors, but you need to look at what is actually the data and then try to make estimations from how the data is structured on what does this data represent. And that is where I think we need to have semantic models, we need to have context systems that are context aware and understand the intent of both the devices and the people that want to consume this. And I think that is, we are just in the start of that, and it's going to be really interesting to see how this evolves over the next coming years. So.
Right. And I also would like to add a thing when you talked about the case of the lamp, that I don't see it being a big issue with the processing power. This is a question of critical mass.
Well, now it might not be.
Well, no, but the thing is, right now, you design product based on the requirements. And if you're just going to set up connectivity, use Bluetooth to send the data to a smartphone, whatever it might be, then you're going to dimension the design and the CPU for that purpose. Mm-hmm. If you actually say that, well, it's worthwhile to apply more intelligence, then you're going to go for a slightly better and slightly, at this time, more expensive CPU, yeah. And when that increases volume exponentially, the price drops almost exponentially.
Right.
And then that kind of creates the next generation. So I don't see it as a big limitation, the CPUs that are embedded today, like an M0. Of course, we can't do black magic. There's not a lot of things we can do on that small of a CPU platform. Pretty early up in the value chain, we can start doing things. Then you don't want to do everything. You don't want to run all kinds of deep learning methods on a very small CPU. But you're going to see that they actually push the boundary because they see the value that it's worth to add this cost on the hardware for the premium products, because you're adding premium functionality.
Right. Well, if it becomes an essential part of the product itself, it makes economic sense to move and get economies of scale.
Yes.
But I think that's part of the problem, but I think it's also that traditionally you look at the business case just for the product itself, but the big transformations in most industries is that the services business or the aftermarket business is getting increasingly interesting for the product developers and resellers of products. And meaning that if you have too low specifications on the hardware, you limit yourself on the possibilities on the services and aftermarket business. And I think that is also where we see a change now, that you are prepared to take a risk on increasing the cost for the hardware, because you know that will help you on those aftermarket and services sales as well, to have a higher level of digital and software-based services generated from the devices.
I, for one, was disappointed that my washing machine didn't support plugins that I wanted to add. But
it's probably more about you than...
Yeah, I was going to say.
But, okay, so we're talking about devices. We took a couple examples of devices that are in people's homes, lamps and that kind of thing. What kind of privacy issues are there, both in corporate deployments, B2B deployments, and in private deployments that are specific to IoT? So we spoke a little bit before about data that comes from these devices, such as whether a lamp is on or off. That's not necessarily on its own, without context, private data, or it isn't, for a fact. But in context, it can very easily become, and especially in combination with AI, which can analyze the data and make sense out of it. So you had a very nice example that you talked about before.
Yeah, like the automower.
Yeah.
Yes. And the thing, I mean, I love the automower in the context of a consumer case, that I don't want an automower to learn a garden or know a garden. I want it to know my garden. It should know where and when it should operate. I don't understand why I have to program it. It doesn't make any sense at all. It should actually know when it should operate at a maximum and thereby reduce the consumption. So it's going to learn a lot of things, and it's going to pick up things as it's walking around my garden for thousands and thousands of hours. And on top of that, we're going to add functionality. For example, if I switch on like a vacation mode, where I tell it not to go into places where it typically gets stuck, because I don't want it to get stuck, then that is almost the same thing as posting on Facebook that I'm on vacation.
Yeah.
You don't want to do that, because someone might actually pick up you're on vacation, and that might be a burglar. So you're absolutely right. There are cases in context where you have to think about the privacy question. And I think this is another reason why, when looking at edge and cloud, that some things actually should stay on the device, which is my device, and I don't care if it stores it on my device if it's not accessible to someone else. That also applies actually on the B2B side, because we have machine manufacturers and they have their customer, and their customer might be a public company, and they don't want the manufacturer to know when they have production faults or the production rates. So all the data needs to be processed on premises and just send the conclusions to the manufacturer so they can support the machine. So privacy and information leakage and all these things come into play very much when it comes to IoT and connected things.
And I think that's crucial, really, that you respect privacy and that you are very careful about the data that these devices generate. I think it will be very easy to find scenarios where you will be able to identify persons either in an enterprise context or in a personal context. So you really need to think about that twice, what you actually could do with that data if you start to aggregate it. And I think another part is that if you should trust your operation in your organization to use IoT devices, they need to be secure. And by being secure, they need to be physically secured, but they also need to be good mechanisms to actually monitor what the data is used for and what you do with the data. So I think privacy and security is really, I would say, top of mind when it comes to IoT. IoT will not exist if you don't respect privacy.
That was an interesting example that hadn't occurred to me, was that there can be information leakage, even if it's secure, that if another company can see that your production is down. That's a pretty important insight that you might not want, to leak uncontrolled.
You might be a public company.
Yes.
On the market. So absolutely. But what kind of strikes me is that a year ago, that was the number one question. That was about security. When talking about IoT, that is not the number one question. It's toned down, and I don't know if it's because people actually started to get their arms around it. They haven't solved it. They're starting to get their arms around it. Or if it's that it's too complicated, let's ignore it for now and let's make sure we solve it later. I actually don't know. Exactly. We'll see.
Well, what about GDPR? Has GDPR hit IoT? I mean, is that something people are talking about?
Of course it is, and I think that is also top of mind of many of the scenarios. And as we said, I mean, even though we are in a manufacturing context or we are in a product for B2B, there is definitely scenarios where you need to be careful around what you could do with this data. What data do we actually gather from the devices? Who is actually reporting this data, and could we identify persons? And in most cases you can. So I think GDPR is very important also for the B2B world, particularly because there's humans in these processes, and of course there is also data that is generated from those processes that could reflect what persons do. So I think security, at least for me, I think security still is a top concern for my customers, at least. I mean, in pretty much every conversation we have with a customer, there is questions around security, and it very much comes down to building that trust on the platforms, and how could we, from a Microsoft standpoint, deserve that trust from our customer. And for us, it's security, but it's also transparency. So being very transparent how we store data, where we store the data, and being very clear that the data is owned by the customer and not by us. It's always the customer's data. And I think that is when you start to have, if you take a manufacturing environment where you have those value networks, you need to be careful also around the insights that you actually could get from about the other actors in the value network. Like you said, that if you are a supplier of parts into a production, you could start to see from how the parts are being used, how is the business or the production going for other actors, and if you just get data from screwdrivers, for example, in production, you could start to analyze that data and actually understand how many faults do they have in their production environment. Right. So I think GDPR and I would say also information security, you need to think carefully about that, because it's not just about the data you get, it's also from the insights you could get from that data, and how you could spread things around that data, so to say.
Right.
So.
Well, transparency is very important, and I was speaking with Jean-Michel Franco from Talent this morning about GDPR in specific, and he said that one of the main things that will help you avoid litigation is being open and honest, because it's not clear whether you're compliant or not, and so reducing your attack surface is being open with exactly what's going on with the data, how you're handling it, and what you're doing. I have to say I was personally disappointed this week because I figured out that my car, I had unknowingly opted into selling all my location data with the connected car to third parties. I probably would have gone along with it if I'd known about it, but it bothers me that I didn't know about it. That's more of an issue than actually sharing the data for me, because, well, I expect them to take the data, but the fact that it's not clear makes it a bit bothersome.
But I think that's a good example how it shouldn't work. I mean, you need to be transparent about what you do with the data, and that comes back to the trusting as well, that if you should deserve that trust, you need to be both transparent, but you also need to be able to actually be certain that the data is secure. So you don't want the data to be taken by somebody else that had other intents than the ones that you have accepted for the data to be used in. So
I also think that what we are talking about, we are talking about digital transformation, and transformation of a lot of old traditional companies that are very strong with the domain expertise in a certain area. They have great products in that specific area, and now all of a sudden they're going to become digital. They haven't had a data-driven business in the past. So for them, this is going to be a radical change, and of course, this might not be top of mind, and it's complicated for all of us to really understand the impact and how to act and manage when it comes to GDPR and other things. But I think it's probably right. Transparency and thinking about it, working with it, and trying doing its best is a good start.
5G is hip. 5G is big. Is it coming soon, and is it going to affect IoT, or is it like any other connectivity before it?
It has to, but it's a technology, and that's the thing. Like all of us, well, it is. Every generational shift is pretty revolutionary, because they're not like slowly. They're jumping incrementally, and then all of a sudden that changes the circumstances, the conditions, enabling us all of a sudden to do full HD When it used to be that you were doing pretty poor SD in the past on TV, and then being able to do 4K, that it actually enables you to do pretty radically new things. It's going to be the same thing with IoT, that we're going to see all of a sudden that some of these use cases that are very data intense will be enabled by connectivity.
So will my Skype calls be a bit more solid from now on?
I don't know, probably, hopefully. but there are a lot of moving parts in this equation. It comes down to the software vendor, to the network, to the operator, and all these different things. And I think, like Charlie said before, that it's going to be the network that's going to be a bottleneck in many cases, because we're going to find ways of consuming that extra bandwidth. We've always done that.
Yeah.
Every incremental step, we found new ways of consuming all the available bandwidth and doing new things that requires a 6G and a 7G. And in my opinion, 5G is definitely a very interesting and important step, but it's just technology.
Right.
And I think what's interesting is 5G combined with other narrowband technologies, etc. Because what I think is really interesting to see now is that we are starting to get all kinds of different connectivity standards and capabilities in place. So if you have an IoT scenario where you just want to have very small data volumes once a day, but you want to have long battery times, there is technologies for that. If you want to have your virtual reality model sent over 5G to your HoloLens from IoT devices, you could do that as well. So I think what is interesting is now to see that there is starting to become a bigger variety of different connectivity platforms, both from a business model perspective, where telcos are being challenged by some of the narrowband technologies like LoRa or Sigfox, for example. So I think that kind of a competition will probably be good for IoT in general, because that will push also all the other actors to actually move forward. But I don't see that 5G is revolutionary by itself. I think the revolution is by enabling those new scenarios.
New types of services.
Yeah, definitely. And there is scenarios today that we can't do because we don't have the data throughput in the cellular networks, and 5G will definitely unblock those. But I think, as I said, I think the requirements and demands will increase quicker than the standards will be there. So I think we need to find other ways also to still do workarounds, even though we have 5G, because that will start to be a limitation as well when we come forward. So.
Video games and entertainment always manage to push the market forward.
Yeah.
Yep.
Well, I think one question that our viewers have been hoping for the entire day, we haven't really spoken about it. So I'm wondering if it affects IoT, and that is blockchain. Blockchain technology. It almost, I resent almost having to say just blockchain because it's such a catch-all nowadays. But I think that there are perhaps some use cases when it comes to tracking items and that kind of thing. Do you see that there is an intersection with blockchain technology and IoT, or is that just two hyped up things in one place?
I think it's a strong buzz around blockchain, no doubt about that. And we have done some tryouts, or have customers that have done some tryouts. The limitations we see with blockchain today is really the transaction time that it takes. If you have big volumes of transactions where you want to secure them with blockchain, we see transaction time actually being a blocker. But the concept itself is really interesting to actually have trust entities that together themselves could agree on what is actually the trust base that we have between each other in supply chain, for example. But at least from my experience so far, I think it's a little immature for having at least high volume transactions because of the transaction time. That's my perspective to that, at least.
I'm a startup, so I have 2 out of 3 buzzwords in my bingo. So I have IoT, I have AI or machine learning. I would love to have blockchain. No, but seriously, I think that in comparison to 5G, for example, this is more of a concept than technology.
Right.
And there are a lot of very interesting conceptual things when it comes to blockchain of removing a trusted third party.
Right.
That becomes like a central part. And especially in times like this, when politically we have forces around the world that might not be trusted parties from a political point of view, that are sitting in very strong power positions, then actually distributing the power to the people is a very compelling value proposition. So I love the concept. I think that it's gonna actually generate some very, very interesting evolutions of business models and actually create some really, really cool things when it comes to how that concept is being applied.
Yeah.
So I hope for it, but still it's a bit immature. We haven't seen much of it. We don't work exclusively or specifically with it.
Well, I think people are seeing both the benefits and the disadvantages, and it's probably only highly technically savvy people that have been able to use it, which is why they only see the advantages. A lot of people probably need the hand-holding that a trusted party in the middle provides, such as the ability to reverse transactions and that kind of thing. And so maybe it's not possible that everybody uses these fully autonomous, fully trusted distributed systems. I guess history will tell.
Absolutely, but the thing is also just like IoT, why is it happening right now? Yeah, the price on sensors and CPUs are going down, all these different things. But it's also because everyone's talking about it, that we kind of generate a momentum that sets this snowball rolling, and all of a sudden it starts happening, and it starts happening at scale. I mean, there's not a single CEO out there who can ignore the threat of technical disruption.
Right.
They used to be able to discard, say that, well, we've been around for 150 years. Nothing can bring us down. No one is actually being that disruptive in our industry. And then they've seen all these examples of anything from the music and video industry to whatever it might be. Everything is being disrupted. So once that momentum starts going, then all of a sudden everyone starts looking at this, and then they start putting in the domain expertise, and then they start doing things. And I think this is a very important thing when it comes to IoT, and especially in the combination with machine learning and AI. Do small wins. Don't try and boil the ocean. That a lot of these things that we talk about are grand, tremendous things that you would love to do. But at the end of the day, start small. If you can actually solve a small, like we have Alfa Laval as a customer, we look at 4 or 5 sensors, figuring out when you have to do maintenance. And they have maintenance cycles of anywhere between 6 weeks and 5 years. So of course, if you can learn individually for each and every heat exchanger when you should do it, based on different conclusions, that's extremely high value, and it's pretty basic as a use case. But it's very valuable. Small wins.
Well, I've asked other panelists earlier today what reasonable cycles are for projects. And we have our idea. You know, we do big data and machine learning consultancies, and we think if a project takes a year, it's often the case that at the end of the year, you don't even remember why you started in the first place, you know, and that kind of thing. So what do you think are reasonable timeframes for having these projects? These are words that have come up time and time again today in our panels: speed, collaboration, executive sponsorship. So I like that you said small also, so I'll combine that with speed there. What kind of projects are we talking about? How big should they be in order to make them successful?
You're absolutely right. If it takes a year, that's an eternity, especially for a startup. I can go bust in a year. I mean, we need to go where the money is right now, where things are happening. Right. And I think that this approach of thinking like a roadmap, small wins, you add constantly new features, and they're not used to that. They're used to having a machine, and then they do the next generation of that machine, which is within the same silo, within the same part of the organization. Now they're doing a digital transformation project that goes cross-functional across the entire organization. They don't have the processes and the people for doing that. So they don't have the playbook.
Right.
And that kind of stalls it. But if you can actually break it down to say, you know what, let's just do it for the heat conversion. Let's just find one issue that we solve and just push it out. It might not be as beautiful as we want it to be, but that at least gives executive sponsorship to take the next step and the next level and getting the people involved.
Time. 3 months, 2 months, 1 month,
Well,
how long?
I think it very much
What's
depends.
reasonable though?
But what I see is that we are moving away from doing investigations, of doing POCs or pilots where you really want to try out the technology, because that 3 years ago that was a pretty common thing. We actually want to evaluate the technology, and what is happening now is that the technology itself is maturing so quickly. So if you do these kinds of evaluations, what you actually concluded as a result from that is not true anymore, because there's happened quite a lot of things during the 3 months. So I would say, agree with you that you really need to keep it small. You need to start with what is the requirements that you're looking for the next, I would say, month or 3 months. I think that is a pretty good
1 to 3 months.
Yeah, I think that is a pretty good time frame to focus on. And then you could have ambitions. What is my 1 year ambition? But when 1 year in this world now it's a lot of time, because there will be so much innovation coming from a technology standpoint. Your competitors in your industry, wherever you are, will have changed quite a lot in the next coming year as well. So your requirements on your business and how you should position yourself will most likely have changed as well. So I think, don't think too far into the future, because you don't know what the future look.
Right.
Prepare for change, because you definitely need to be able to change, and look what you really could affect in the next coming month. I think that's a best practice for IoT.
Right.
Yeah, I was going to say the same thing. 8 to 12 weeks. That by then you should have something that you can show that can if not be a publicly launched product, at least it can get internal buy-in. So take that approach, because what you're also going to do is that you're going to learn so much in the process that you're basically going to redefine the product in many cases. That, wow, what if? And then you're going to figure out that I actually would like to have these sensors as well, because then I could. And then you get someone else who kind of throws something into the whole idea, and then it kind of evolves and becomes something else. And then it's better to transform with that and end up with a better product than doing all the rigorous processing and delivering a perfect product that is way too late and was perfect theoretically, but not in reality.
This is quite a far cry from the ERP projects that were 3 years plus and that kind of thing. I don't think a lot of organizations are ready to mobilize. I know we've had customers where they've said, 1 month, that's awesome, let's do it. And then we start, and where's the guy that knows this? And then the month is over and they haven't even been able to get their data, and how can we work?
Well, that's why you need a solution partner. You need someone who actually owns the solution, and then use technology that is flexible, and that's what we're seeing. I mean, on the IoT platform side, we're basically seeing Azure and your other competitor from Seattle. That's what we're seeing these days. That because it's programmable, because you don't know if you actually buy functionality when you finalize that project. In many cases, you realize that was not the functionality we were looking for. So you're looking for a very programmable environment, and that's also what we bring in. We bring in a programmable edge computing solution that you can configure, add more, and kind of develop based on a roadmap. You want to configure it because you're going to find out things in the project in those 2 to 3 months of what you really want to do, and then you want to be able to shift slightly direction to get to where you want to go.
Well, I think it's beyond doubt that the cloud is ready to rock right now, and the question is, data governance and all that kind of thing, is that going to set a stop? I mean, are you going to be able to find the people that are responsible for certain data streams, getting the people together to collaborate, or what do you see as the greatest hindrance to implementing a good IoT strategy?
I think it doesn't have much to do with technology at all. I think it's still the culture thing. I think it's that you need to have the right people in your organization to actually have a different way of work. You need to look at your processes. If you are an enterprise, I mean, the capabilities that IoT could provide when it comes to having the telemetry from products, having that insight on how your customers are using your products, you need to change the way you work internally on reacting to that data to make that data valuable for you and then generate increased value for your customer. So I don't think it comes down to technology by itself. I think it's very much a cultural adoption from an organization, and I think that is the main reason that IoT projects stall today. It's not that you have, I would say, data issues when it's data quality or even technology. I would say it's much more the people and culture readiness who should own this solution. How should we drive this as a product? How do we drive this as a service? And I think that is where we see most of the blocking happening today. It's not about technology itself. I think technology today is very mature, even though it changed quickly because we add a lot of innovation both on the cloud side and on the device side. But I think where we really need to step up is on how we adapt and how we are flexible about adapting from an organizational standpoint. So I think that is, it's more about the people and the business than it's about technology.
All right. If we step back a little bit, it's the last panel for the day. I want to talk about something that is that I find quite interesting. because I work with it, and that is smart cities, devices, and all that kind of thing. What kind of momentum do you see with regards to smart cities? Is that happening, or is it still far ahead of us?
I think that smart cities for me could mean quite a lot of different things. It could mean that the society around the city use open data to get insights around the data that is run in the community of the city.
With regards to IoT then?
Yeah, so it could also be that you have, for example, smart traffic lights and you have those integrated systems,
right,
etc. And I think we are in very early phases of making that happening today. And I think the main reason there is that we have too many standards, or we lack agreed standards. How do we actually exchange the information between these, in many cases, legacy systems with new IoT platforms? And I think that is, in those cases, it's very much down to building the information models on how we actually could get data and understand data and how we could compare data and make that as easy as possible. When it comes to buildings, for us now, it's just exploding the interest around buildings. I did a session on that.
Sensors in buildings?
Yeah, and it's not just sensors, it's also around that buildings are, the environment around buildings are changing, that in the sense that if you look at an office, for example, it's becoming a place where you don't have your fixed table and you are sitting at your workplace. You actually want to have different environments. You want to have somewhere where you could concentrate. You need to have somewhere where you could be creative and where you could have team meetings, etc. And all of this, you could make a better decision around where you should be if you have data that support your decision making. And if you are a retailer today, the physical store is becoming much more of an arena for an event than actually a showcase of your products.
Right.
And retailers are also increasingly more interested in getting data around what is actually happening in the building and what is the dwell time of the people, where does people stop, etc. Mm-hmm. And I think for that reason, now combining also the core data that you have in buildings like ventilation, alarms, and passage control systems and everything. If you combine all of this, you could start to make really clever use of your buildings, lowering energy consumption. And I think this is scenarios where it's really exploding if you look into the building. So what I expect as a next revolution is that when you start to set those standards now, is that buildings, you could start to have communication between buildings as well. So this world of having a control inside your building will open up, and then you could start to look what is the spaces that are around my building, etc. Right. But I think we are still in early phases of this, and it will be really interesting to see how this evolves over time.
I agree. I mean, buildings, that's more of a contained environment. You have less dependencies on other parties. That's the thing with smart cities. You have a lot of dependencies. Right. And I think that there are actually, if we look at Sweden, I think that there are some learnings we could actually take from the metro networks. Mm-hmm. That we started doing some 20 years ago, where you started building out some infrastructure. And then those that were most successful actually had their own customers, like other municipality-owned operations that actually became customers. Mm-hmm. And then that kind of justified the investment, and they started actually being used, and when it starts being used, then it starts becoming real, and then you actually face all the real issues, and you create a solution that works, and then others can tap into it. That kind of creates the momentum. But there are a lot of dependencies, which is why it's going to take some time. There's a lot of opportunities. There's a lot of very interesting things and cool things you could do in terms of smart cities, but it's going to take some time. And I think once again, small steps and bring it down to a certain level, manage expectations, because then eventually, when everything's built out, then you can actually hop around and have the same expectations on all the different cities. It's kind of hard if you have a car that depends on smart parking and whatever it might be, open data from smart cities, right. And all of a sudden you drive into a city that has nothing.
Yeah, that would be disappointing.
That would be disappointing. So I think that's the big challenge, that you have a lot of dependencies.
Right. But we have a customer here, for example, Mälarenergi, that were showcasing their solution for distributing heating, where they saw huge business values of communicating actually with the houses to understand what is the pattern at each of the houses and when do they need heat, and then understand the grid of that distributed heat. Where do we lose energy, and what is the energy that the houses need? So when you could start to use those predictive analytics for the infrastructure of a city, there is a significant savings that you could do around both detecting waste, so see if we actually have a leakage because we didn't know this before, but also being smart around how you generate and consume, for example, heat in a city. So I think there's a huge potential that we need to establish these connected ecosystems around cities, because that's the only way we could meet the requirements of urbanization together with having less resources to actually manage the city. So we need to be smart around that, and for me the answer to that is really to have connected platforms that could use smart algorithms to understand and control those systems. So.
Right, makes sense. Well, that was all the time we had for today.
Okay.
And that was the last panel for the day. Hope you guys enjoyed yourselves. Hope you'll be back next year for Data Innovation Summit 2019. Thank you, and I'm signing out. grekisk pose.
So wrapping up Data Innovation Summit 2018, what is your conclusions and what have you heard so far today? If we start with Anders.
It's been really a great mix. I've been at the machine learning and AI stage, and I think one of the most obvious themes is that machine learning and AI is no longer one of those experimental, exciting projects far ahead. It's really been integrated in the core of many businesses, and it's really high on the agenda on many businesses. So that was visible. There was a lot of talks on rather how you productionize efficiently, how you serve models, and all these aspects that it comes a bit later in the process. Towards really productionizing machine learning and AI. So that was really obvious.
You can really see some case examples now and collected data. If you look 2 years back, then we were talking about, as you said, Lars, before the future, but now we are in the future. So
exactly. You could actually observe companies that have done things. Right? If you go back a couple of years, you would hear a lot about plans and things that are important and the visions we have. Now we saw a number of like data lake and data platform projects and actual real learnings from these projects, and that was great fun to see.
Thank you. David, and you mentioned I heard you mentioned something interesting today. It was something about a book, and what was that?
Well, the funny thing was I spoke with a number of panelists today, and many of them spoke about the same things. The book that everyone mentioned was Weapons of Math Destruction.
Sounds lovely.
It's a pop book, and it explains a little bit how you can go wrong with statistics and that kind of thing if you're not careful. And so why it pays to be a little bit aware of how statistics can be used properly and how the scientific method works in general.
Yeah, also in my panel we're talking about when you have the anomaly where there is something that is actually an error or something wrong with the data, and how do you handle that? So do you have any examples of what could have gone wrong when the data or when you...
Well, this came up in other discussions when we were talking about how AI can be biased potentially, and understanding the concept of confounding variables and that kind of thing, where a model might not be wrong, but the explanation might not be as simple as what it seems, because there might be confounding variables that are hiding what the real cause of some prediction is.
We'll come back to you with the GDPR thing. But,
on our end, there was surprisingly little talk actually about the ethics and maybe bias in AI. I think there's one interesting discussion that came up that's there's a lot of criticism around how bias can be built in these automatic data-driven systems. But it's also, I think, a big opportunity in actually quantifying and isolating that bias and doing something about it. And we had some talkers saying that it's easier to do something about a bias that you can identify in a system than the bias that's in all of us humans. I think it's also an opportunity to actually remove and improve how bias is built.
It can be very systematic in how we analyze those biases, and actually I think this is an opportunity rather to remove biases than the other way around.
Yeah, that was one of the conclusions that came up.
Do you have any examples of opportunities, the positive things of how you can use data from now and in the future connected to?
I mean, there are these, a bit sad, obvious examples of like face recognition working much better for white male than women in general, or just because of how what data is available and what data has been used for training. But if that's the case, then you can really prove it and test it in the system and prove that it's there and do something about it. If this discrimination or aspects is just in our heads, it's really hard to really prove that it's there when it's in people. If it's in a system, at least you can
change the data set.
You can test it and prove it and do something about it, I think.
I think we'll see regulations down the road in this area. I think GDPR 2.1 will include regulations such as you have to prove that your systems are unbiased with respect to gender or race.
It's a bit interesting because you don't have to prove that your board members are non-biased, that your personnel is non-biased. So that could be positive. I mean, that you actually, when it's built into a system, a lot of more high-level decisions, suddenly you can start actually testing and proving whether it's biased or not. So that's
so interesting when most of the companies are always cross-border, and if you look at how data is handled in one country and compared to another, if we take an example with UK, most of the cases you do tell your sexuality, or you do tell the background that you have, that in Sweden is normally not legal, or it is not legal. So when you collect that type of data and you share that, then you have all these challenges. Lars, what else did you bring with you?
Well,
from the day?
There was a lot of talk about the GDPR, obviously, since this is GDPR spring. And my observation in general about GDPR, both in the presentations today and among the companies that I have observed, is that people have very different angles on GDPR. Like some are not worried at all. If we just started, we should probably be fine. And some are very scared and throw away data, or there's even one company leaving the EU market. And on the other hand, some of the most technical competent companies are in very good shape in terms of the GDPR, but those are only a few.
No, that's super interesting, and we talked about before. That's what's going to happen is, of course, the pilot cases. Unfortunately, that's going to come, but that's retro, or that's reactive. Instead of how can we be proactive? How can we simulate and think what could go wrong? I know, David, you mentioned something before about the 2 points and how you can analyze and guess the person's.
I think there's many situations where it's not going to be clear beforehand exactly how the law is going to be interpreted. And so you might have data where you think you've done your best, and only time will be able to tell when somebody's taken to court and will have to prove, in a court of law that they did due diligence or whatever it takes. So I think that's the way it's going to go. Somebody will have to be the sacrificial lamb eventually.
Yeah, with the agile system, let's in 2 years or 6 months' time apply some nanotechnology to this, and then whoops, we found something very interesting in the system.
But there was some good advice that I got this morning, which was you can minimize your proverbial attack surface by doing well by your customer. So what you can do is imagine if you had a customer call in and ask for all their private data and ask what you're doing with their data, would you have a good answer? And if your answer is good, that reduces your risk considerably.
Yeah. I think on the AI machine learning track, one I think really sane part of the development is that people seem to talk about AI or machine learning as more of a gradual scale now. I mean, from just any sort of statistical analytics, data-driven insights, to the range out to more AI and deep learning. I mean, it's more of I think before there's been this hype around that it's something completely different than data-driven analytics, and now there seems to be more of a gradual scale between advanced data-driven analytics and standard classical analytics, which I think is quite a reasonable development.
AI versus the ML, now how
it just
collaborate between the two.
Yeah, it seems that now it's more on par with what's actually going on. Like there's all these levels between any general analytics, statistics. The more advanced methods you use, the more, you start calling it machine learning, and then you start calling it AI at some point, depending on what situation you are.
I think we see applications in that gray zone area, like predictive maintenance and outlier detection, or on the borderline between machine learning and analytics. And we saw some of that today. Yeah.
There's not such a distinct difference, distinct boundary between old methods and new methods. I think that makes sense to me. I think it's a good development.
Some of us had more B2B stages, and the interesting part of when we talk about the heavy asset industry, for example, when you move from offshore to onshore, or in mining, where you are not as much present in the mining anymore, but you're actually in your data house, or you're sitting somewhere else, and how do you keep the communication between the data scientist and the people working at the spot? There was a great example about, and I don't remember which company, but it was about the captain of the ship getting instructions from the data, data scientist as the dashboard, and the captain said, of course, why should I listen to you? you should drive 12 degrees through the storm, and he's like, what's your experience about this? So what they did was that they put the captain together with the data scientist for a while, so they could really start to communicate and understand each other's language. I think it was a great example for how do you work across departments in organizations, with the business, with the digital part, to collaborate more and actually enable these solutions. Do you have any experience from?
Machine learning is definitely a team sport. I mean, you need several different legs in order to build a machine learning product. You need the data science, of course, but you also need the data engineering to actually turn it into a product, and you need a sort of a business angle or product ownership angle in order to make a product that provides real business value. And I've seen several examples of where this balance is like tilting one way or another, or where the different parties don't cooperate, and then you can still make things, but you never turn them into real business value.
Who has the mandate and who has the power to lead in one way or direction projects?
Well, that has to be a balance. I don't think it can work well with the balance, and it's up to leadership and management to make sure that you have these mixes, the right mixes in the team, so that people can learn from each other. And it's also the tooling also matter. If these people work in different types of tools, then they won't communicate and collaborate. If they can work in the same types of tools, they can.
How do you enable from this spider net of so many different type of applications and platforms, and being agile to collaborate, and then add on top of that in the future? I mean, we shouldn't even go into talking about the bags and with the old system, but in all the industries, do you have any good insights on that from today, where they have some good solutions, where they have combined multiple different type of platforms or applications and been successful with that?
I don't know if I have a good answer to that, but it's really clear the trend that you're trying to create platform-based applications that to solve like more holistic view on making it easy to, on a really high level, like in machine learning and AI, to solve complex problems, to remove all the dull, repetitive tasks, and make it really easy to solve complex problem with a simple graphical user interface. I mean, we had some presentations on graphical user interface for really efficient data exploration without needing too much knowledge on how to use databases, how to really do data crunching. And same as Luca from Peltarion, they're offering a platform, very holistic platform for doing all your AI modeling in-house. And I think this is an obvious trend. It's still up to proof, like how efficient they've solved these problems and what the limitations are of these products. But there's a lot of those products being developed at the moment.
We saw a good presentation from Klarna on the subject, where they have, under a number of years, built a self-service platform, and thereby lower the requirements on the users of the platform to have like developer experience or engineering competence, and so that analysts or data scientists can go in right away and benefit from the Hadoop-based infrastructure they have. And that platform looks at a glance very similar to what we built like 5 years ago at Spotify to make things self-service. And these are obviously mature companies, mature data-driven companies, where with hundreds of people getting value from data on a day-to-day basis. But I think that's the path that we will see for other companies as well to follow, but lagging a few years behind.
So what do you think is going to happen in the application-based open source and the collaboration between external parts in the future? It's a very, very open and broad question. You can kind of, in terms of value, for example, and the opportunities that come, you can kind of compare with your organizations when you are able to start to collaborate externally and create your ecosystem with other components, other sponsors or partners within the system. I'm getting you somewhere completely different now. Okay, let's jump back to GDPR Spring. I love how you said that.
I actually have an answer to a partial answer to your question. I think. I think the traditional proprietary vendors are facing a challenge here. They are still selling well to the enterprises, but not so much to the disruptive companies. And if you talk to them, they often have an attitude that, well, if you just put all of your data into our platform, everything will be fine. Whereas the modern companies, they go to open source and they go to the cloud. And if you use either open technologies or cloud technologies, you get a bunch of building blocks and you integrate them yourself, which is very different from the sort of holistic platforms that we've seen in the past. And these sort of holistic companies, they have a challenge ahead of them in relating to that movement. And I've, in some cases, I've observed them, doing okay, having integrations with Hadoop and the cloud and so forth in a way that's reasonable. In some cases, I've seen them say, "Oh well, you can't use Git or versioning control tools without our commands. We have our own version control system." And that's no. Then you go to somewhere else, right? So there's a challenge in this move towards more openness and more bits and pieces that you put together.
Cultural thing of you already built something, how will you bring something new in, and what's the value and the purpose of?
But people expect tools, components with a smaller scope these days, but that do one thing really well, and that's how all of the disruptive companies, those are the building blocks that they use. And I think we will see a trend there. I'm not sure it answered your question or not.
No, it was some good shared insights. That's the point here. David, what do you think about that? About being very specific in the value that you bring? I guess we're talking a bit more about the consumer B2C side or B2B as well. Did you see that?
Bringing value to customers and that kind of thing?
Yeah, exactly. You can just pick up anywhere you like.
Well, I think one of the fact of the matters is that we're here talking about innovation, and if you're trying to be innovative, meaning coming up with new ideas, you can't come up with the same idea everybody else has come up with. You're going to try and do a new trick and bring new value and get a competitive edge and do all these things by copying all of the other your competitors and buying the same tools as them and doing all the same tricks as them. That's not going to give you a competitive advantage. And well, you can bet on that your employees are 10 times more intelligent than your competition's employees and can use the existing incumbent tools better than the competition, and that might be the case. But it's likely not the case. And so the only recourse is to go to cutting edge stuff, and you have to find a balance that works for your company. A recurring theme, though, in the panels that we had today was that everybody was saying that today's tooling, although it is a bunch of building blocks, seems very reasonable to expect that you can implement something useful in 1 to 3 months, which is a far cry from these 24 plus month for ERP system integration projects that we've seen historically. So speed is the key here. Every company can afford to spend 1 month on something that is potentially high value. And so what we've found in some of our engagements at Lake Tide is that it's not even the speed of implementing data science, but rather the companies themselves culturally aren't ready. Oh, who is it that owns this data? And that kind of thing. You'll feel that companies aren't even ready to react that quickly. So the speed of innovation is happening rapidly, and the tooling is ready to help you do a disruptive project on short notice if you're ready as a company.
Yeah, we have the technology. I mean, we had VR, artificial intelligence, since the 30s. So what's the problem here? It's the people. How do you make the organizations move with this? So at Disrupt Synergies, we do the simulation with, for example, the test beds, and the UK have the regulatory sandboxes where you can actually simulate on pre-hand. Maybe you do that as well at your company, where you can test and simulate before you actually roll it out in action, and you create this environment where it's kind of an acting environment with different components, both the digital but also the interaction with the behavior from consumers, etc. It's kind of a minimum viable product tested. And I think what we heard from the IoT stage is that this design thinking and testing a minimum viable product, being closer to the customer, that's has been repetitive over the panels throughout the day. Can you relate to that from your stages?
Well, again, we saw some good examples at Klarna where they pointed out that it was really easy to throw out new data pipelines and run several versions in parallel, and that's how most mature companies work with Hadoop or with data pipelines in the cloud. And this gives a much higher speed of experimentation, because you can, without disrupting the existing production infrastructure, you can test multiple things in parallel and do experiments. And whereas with sort of traditional non-big data techniques, every experiment that you did was potentially destructive. So there was less isolation, and that is a paradigm that I believe brings much higher innovation speed.
From the linear to the non-linear.
Something like that. Yeah.
I guess we could be standing here all night, but also we have some people waiting for us, wanting to come up here. So I guess we're gonna say thank you for tonight.
Thank you. See you next year. Hey guys, it's time to wrap up the Data Innovation Summit 2018. It's been a fantastic day, 1,200 people, a lot of interesting speeches. My name is Henrik Göthberg. I've been the chairman for this event, and you had some wrap-up notes before. So first of all, I just want to make a big shout out and thanks to all the participants, all the sponsors. It's been an exciting floor to watch today. It's really the ecosystem of partners, consultants, vendors that covers the whole data analytics space. Some of the key takeaways from me as the chairman, being here chairman the last year since we started this, we really grew in terms of maturity, in terms of how many participants we had. One of the key interesting things to close off with is really to highlight is more and more focusing on the outcomes. It's more and more focusing about not only what the data is all about, or what the analytics is all about, what's the decision all about, and what's the value all about. So that's one key thing. The other key thing is
The main questions are about how to operationalize, not to do sandboxing, not to prove something, but how to operationalize. That is exciting. So once again, have a good day, have a good night. I wish you be here next year. See ya.